Hey guys, so tonight I want to take a look at how do we make this thing right here, y equals x squared plus 2x plus 3, look like this, y equals x plus 1 squared plus 2. And we're going to see in just a moment that these two equations are actually the same equation. They're just written in two different forms. So we took a look at standard form the last couple of days in class. We looked at how we could potentially graph or learn something about the way that this quadratic function looks. And we can do that by finding its roots, or we can do that by finding its vertex. And those were kind of some of the things that we were doing in class. What we haven't yet seen is how we can turn this equation into y equals x plus 1 squared plus 2. And the value of doing that, if you think about last week's lessons, is that when I have my equation written in vertex form, the vertex is given to me because of the transformations. We know that that plus 1 is going to move this to the left by 1 unit, and we know this plus 2 is going to move it up by 2 units. So if we think about starting a sketch of our graph, before we really even begin to do any math, we already know where the vertex is when we can write it in this form. It's left 1 unit and up 2 units. We have a vertex that's starting right there before we even begin. And because this doesn't have any stretch, there's no number pushed in this position that's stretching it, we now know from that point we're going to go our up 1 over 1, up 3 over 1, etc. We can get a graph of this function without doing a lot of algebra, a lot of math. So I want to show you how we do that. And so we're going to start back with this question, y equals x squared plus 2x plus 3. And in order to write this in vertex form, we're going to start through the steps of completing the square. So the first thing we're going to do, just like completing the square, is we're going to subtract 3 from both sides. And we're going to get y minus 3 equals x squared plus 2x plus blank. And of course, since we put a plus blank on this side, we need to also have a plus blank on the other side. The only real difference between completing the square that we had done previously is that this would have been a 0 in the past. This would have been a 0 in the past. And instead, we're leaving it as a y, because at the end, we still want to get back to a place where we have an equation that says y equals something. All right, so we think about that little t-chart for just a moment, and we're trying to build the number 2, and we're going to build that with 1 plus 1. And 1 times 1 is 1. So the number we're adding to both sides of this equation is 1. We are then going to go ahead and use our t-chart to write this as x plus 1 times x plus 1. So that's us factoring here. And on this side, I'm going to combine the like terms. I have 1 and negative 3, and that's just negative 2. So I got y minus 2 equals x plus 1, x plus 1. We're going to simplify this to write, instead of x plus 1, x plus 1, we're going to write this as x plus 1 squared equals y minus 2. And finally, again, this is somewhere where completing the square is a little different. Because our goal is to get something that says y equals, we're going to now isolate this y again. Now that we have this written in this form right here with x plus 1 squared, we're going to go ahead and bring back over this 2, and we're going to end up with y equals x plus 1 squared plus 2. And again, that's helpful because it tells us the transformations. This transformation is a left by 1, and this transformation right here is an up by 2. So if I wanted to go ahead and graph this, I would start left 1, up 2, and from there, from that point, I would go ahead and go up 1 over 1 on both sides, and then I'd go up 1, 2, 3, and over 1 on both sides, and I'd get my parabola. Alrighty, so I want you now, given what we just did, if you need to refresh, go ahead and rewind the video, but I want you to try this next question. I want to see what you do to convert this from standard form into vertex form. Go for it. All right, so let's see if you did it right. First thing we're going to do is we're going to clear out that c term, and we're going to get y plus 3 equals x squared plus 6x plus blank. And because we did a plus blank on one side, we've got to do it on the other. My 6 is going to be made up of 3 plus 3, which means the number that I'm adding onto both sides has to be a 9. Put that on both sides. This side's going to become x plus 3 times x plus 3, which is just x plus 3 squared. And on this side, I will combine my like terms. 9 plus 3 is 12. So I have y plus 12 equals x plus 3 squared. And finally, in order to rewrite this as y equals, so we can write it in vertex form, we're going to subtract 12 on both sides, and we're going to get y equals x plus 3 squared minus 12. And what are the two transformations that are part of this function? What are the two transformations that you're going to get that you got from this function? Right, so this plus 3 is going to move the function to the left by 3. And this minus 12 is going to move the function down by 12 units. Cool. Let's take a look at a slightly different example now. In this example, what's really different is that we have a leading coefficient here. We never really looked at completing the square with a leading coefficient, but we're still going to go ahead and use our procedure for completing the square here. We're going to see one little difference. So the first thing I am going to do is I'm going to go ahead and move your 12 over. So we got minus 12 on both sides. And we're going to get y minus 12 plus blank equals negative 2x squared plus 16x plus blank. The one extra step here is that before we can proceed, before we can continue with completing the square, we're going to have to factor out a negative 2. We're going to have to pull out the greatest common factor here. And so I'm going to write negative 2 parentheses x squared, right? Because negative 2 times x squared is negative 2x squared. And negative 2 times negative 8x would give me my 16x plus blank. And one thing that has to change here, this is an important extra step here. When we think about what we're going to be adding on this side, it's not exactly equal to the number we put in this spot. Because whatever number we put in this spot technically also needed to be multiplied by this negative 2. So in order to not forget it, since I've pulled a negative 2 out right here, I'm also going to put a negative 2 right there. So whatever number I add on this side, I'm going to also add to this side. But both of those numbers are going to end up with a negative 2 multiplied to them if we were to go ahead and distribute. So the next thing I'm going to do is I'm going to go ahead and focus on my negative 8. And in order to build my negative 8, I'm going to use a negative 4 and a negative 4, which multiplies to get me 16. I'm going to drop my 16 on both sides. On the right, I'm going to get negative 2, and then I'm going to go ahead and factor. So my x squared will be x and x. And my 16 was going to be minus 4 and minus 4. And on the left, I have y minus 12, and negative 2 times 16 is negative 32. So let's continue to clean this up a little bit. I'm going to get negative 2 times x minus 4 squared. And on this side, I'm going to get y minus negative 12, and negative 32 is negative 44. And my last step is I'm going to add 44 to both sides. And I will get y equals negative 2 times x minus 4 squared plus 44. And this question has 4 transformations. We've got this guy right here, which is our shift up by 44. We've got this guy, which is our shift right by 4. We've got the 2, which is a vertical stretch. And we got that negative sign, which is a reflection. Cool. Last question. I know this has been a kind of long video, but we're really trying to get back into using these play posits to help us get ahead in class. My last question for you is y equals 3x squared plus 12x plus 6. And I would like you to try to tell me what this will look like in vertex form. Go for it. All right, so let's see if we did it right. We're going to move that 6 over. We're going to get y minus 6 plus blank equals 3x squared plus 12x plus blank. Because there's a leading coefficient, the first thing I have to do is factor that coefficient out. So I'm going to get 3 times x squared plus 4x plus blank. And on this side, I'm going to get y minus 6 plus blank. But again, in this blank, because there's a times 3 out here, I need a times 3 over here as well. We're going to split up our 4 now to figure out how to fill in the blank over here. And the 4 is going to go into 2 plus 2. And 2 plus 2 is 4, but it also multiplies to 4. So we're going to add a 4 in our blanks. We will write this in factored form, 3x plus 2, x plus 2, which will ultimately be 3x plus 2 squared. On the other side, we have y minus 6 plus 12. And minus 6 and plus 12 will just become y plus 6 equals 3 times x plus 2 squared. And finally, we will move that number back over so we can get a y equals 3 times x plus 2 squared minus 6. When we look at that, this has 3 transformations. That first transformation there, that is a down by 6. That is a left by 2. And that is our vertical stretch by a factor of 3. It's going to get 3 times taller. And that's all I have for you tonight. So that was 4 quick examples. Hopefully you were able to make some sense out of that. If not, we'll definitely be breaking up into some small groups tomorrow and kind of further exploring this topic in class. But if that worked for you, you now have a new tool, and you'll be able to start using that tomorrow. Alrighty, y'all. Take care. Bye.